Good morning, I am Demetrio Sartiano from Polytechnic University of Valencia, and today I will present a work that aims to investigate the effect of laser line width in a microwave photonic sensing application. So what we did is to use a microwave photonic setup to interrogate a 4-fiber Bragg ratings array. What we did in practice is to extract the frequency response using the electrical vector analyzer and then apply the inverse Fourier transform to the frequency response to obtain the time impulse response. We have a second term in the time impulse response that represents the interference term that is strongly related to the value of this exponential. That is an exponential to the power of the optical path between reflectors and light source coherence length. To investigate the effect of this second term, we carried out 4 experiments, varying the grating spacing and the line width of our light source. 10 measurements were performed, and the variance was calculated using this formula. The maximum variance of the peak amplitude is reported for the 4 different experiments in table 1. In figure 2, I represented the maximum peaks as red dots and the time average of all the 10 traces has a blue line. As we can see in the incoherent regime here, the fluctuation of the maximum are quite low but are still strongly intensity dependent. While in the coherent case, we have a very strongly fluctuation in the peaks. This work is useful in order to give an idea of the effect of the laser line width on the fluctuation when no temperature or strain are applied to our fiber Bragg rating sensor. It can be useful to choose the proper light source depending on the application and on the minimum variance, on the minimum error that we can accept for our application. Thank you.